The last one. All right, here we're finding the derivative of the inverse at 13. So we'll switch x and y. And this is kind of like number 8. We can't solve this equation for y and then do the derivative, so we're going to go ahead and do the derivative first. So we're going to take the derivative of both sides. So 1 equals 3y squared dy dx plus 2 dy dx. So that dy dx represents the derivative of the inverse. So we're solving for that. We can factor that dy dx out and then divide both sides. So dy dx equals 1 over 3y squared plus 2. So in other words, the derivative of the inverse is 1 over 3y squared plus 2. Well, we're trying to find the derivative of the inverse of 13, but here's our problem. 13 is an x value in our inverse. We don't have an x in our equation. We actually have to put in the y value. We don't really know what that is. So we actually have to figure out if this is our x value in the inverse, what's the y value of the inverse? And that all goes back to what we started off with today, saying that the x's and y's are switched around. So that means this is the x of the inverse. If that's the x of the inverse, it also means it's the y of the original function. So we can figure out what this y value is by finding the x value over here. Right? They're switched around. So we want to figure out, okay, 13 is our y value over here. So we're putting 13 in for f of x. We want to know when is 13 equal to x cubed plus 2x plus 1. Now, normally we would go ahead and get everything on one side, so let's start off by doing that. We get x cubed plus 2x minus 12. Can't factor this one into two binomials like normal because we have x cubed, it's not x squared. So another way we can figure this out is using synthetic division, or we could do it graphically. Well, let's do a little synthetic division here. We need to find a factor that goes into this, so it has to be a factor of negative 12, and save us a little guessing. 2 works. Remember, in this case, we have put the coefficients in. There's no x squared term, so we have to put a 0 in the place for that to hold its place. Bring the 1 down. Add these. 2 times 2 is 4, 6, 12, 0. So now we end up with 1, 2, and 6. So that means our function there, really, the 0 equals x cubed plus 2x minus 12. That's the same as x minus 2 times x squared plus 2x plus 6. Right there, 1, 2, and 6. X squared plus 2x plus 6. So either x equals 2, or this whole thing has to equal 0. Again, this one doesn't factor nicely, and we could use the quadratic formula to solve this one, so we get negative 2 plus or minus square root of 2 squared minus 4 times 1 times 6 all over 2a. Problem here is we're going to end up with a negative number under the square root, so that doesn't give us any answer. So that means x has to be 2. So here our original x value is 2. That's the value of f, the x value of f. So that means the y value, so x value of f is 2. The y value of the inverse of f is 2. So we're actually going to be plugging in 2 for y. The derivative of the inverse of f of 13 equals 1 over 3 times 2 squared plus 2. So 2 squared we get 4, times 3 is 12, plus 2 we get 14. So 1/14 for our answer.